Hello, I'm Dave Weininger with the Missouri S&T Geotechnical Labs. Today we are going to go over the laboratory procedures used for particle size analysis. This short video will demonstrate how to conduct particle size analysis in accordance with ASTM specifications. A particle size analysis is used by geotechnical engineers to help easily classify soils. The particle size analysis consists of two procedures. The mechanical sieve analysis involves the use of a series of mechanical sieves to help determine the grain size distribution within the coarse-grained fraction of the soil. The hydrometer analysis is conducted on the fine-grained portion of the material. Material that passes the number 200 sieve is considered fine-grained material. The resulting curves from these two tests can be used to characterize a soil and used to reject or accept the material for engineering applications. The practical applications of the particle size analysis in geotechnical engineering include soil description, quantitative soil classification, and correlations to permeability based on the Hazen's equation. The devices required in order to conduct a mechanical sieve analysis are a stack of sieves ranging from number 4 to number 200, 4, 10, 20, 40, 100, 200, the pan, and a lid, a mechanical shaker, a digital balance, and a weighing bowl. In order to conduct a hydrometer analysis, the following devices will be required: a 1,000 milliliter sedimentation jar, a 1,000 milliliter control jar, an ASTM 152H hydrometer, a soil dispersion device, in this case a shake mixer, a soil dispersion agent, in this case sodium hexametaphosphate, a squirt bottle filled with water, an evaporation dish, a rubber stopper, and a thermometer measuring in Celsius. The soil that we will be performing the particle size analysis test on is a loyal seal silt that was obtained from the Mississippi River Valley. The soil has been mechanically pulverized. Some coarse material has been added to the silt for the purpose of this lab. The documents pertaining to today's lab can be found on Blackboard in PDF format. The particle size analysis is part of a combination lab handout entitled CE 215, Lab Number 3 and 4, Index Tests and Classification of Soils. In addition, ASTM standards of the two tests have been posted on Blackboard. ASTM C136 pertains to the sieve analysis of fine and coarse grain aggregates by the mechanical sieve. ASTM D422 pertains to the hydrometer test. Also available is a data sheet for today's lab. A sieve analysis is conducted to determine the particle size distribution curve, or gradation curve. The particle size distribution curve is a plot of the percentage of soil particles finer versus the log of the particle diameter. To determine this, a soil sample is shaken through a series of sieves. The mass of the soil retained on each sieve is then determined. From this, the percentage passing can be determined. Start by weighing out a sample of 500 grams of the provided air-dry soil. Start by weighing out a 500 gram sample of the provided air-dried soil. It is important to mix the sample in between each scoop so that the 500 gram sample of soil is an accurate representation of the provided soil sample. Record the total mass on the data sheet. Disassemble the stack of sieves and brush out the wedged particles in the screens. Do not use the sieve brush on the number 200 sieve, for this could damage the screen, with the smallest sieve on the bottom, in this case the number 200. Pour the soil sample into the top of the sieves. Place the lid on top of the stack of sieves, and with 2 hands, carry the sieve stack into the shaker room. Load the stack of sieves into the mechanical sieve shaker. Place the shaker lid on top of the stack of sieves. Lower the shaker hammer and turn on for 10 minutes. Remove the shaker hammer, take off the shaker lid, and with 2 hands, remove the stack of sieves from the shaker and carry into the other room. Empty the material in the pan in a bowl and record the weight. This material is the material that has passed the number 200 sieve. It is considered the fine-grained portion of this material. This material will be used in the hydrometer analysis portion of this lab. Compute the total retained mass by adding the individual masses retained on each sieve and the pan. The total mass should be within plus or minus 2% of the original mass. If there is a greater difference than this, the test must be rerun. The percent passing a specific sieve is 100 minus the summation of all the percent retained on that sieve and the sieves prior to it. To determine the particle size distribution of the soil particles finer than the number 200 sieve, a hydrometer analysis must be conducted. The hydrometer analysis measures the change in specific gravity of a soil-water mixture over time. As soil particles fall out of suspension, the specific gravity of the soil-water mixture decreases. The application of Stokes' law to falling spheres is used to determine the grain size distribution of the particles falling out of suspension. Start the hydrometer analysis by weighing out exactly 60 grams of the soil left over in the pan from the mechanical sieve analysis. Record the weight of the soil obtained on the data sheet. In a small evaporating dish, mix the soil with 125 milliliters of 4% sodium hexametaphosphate. Cover with a wet paper towel and allow to stand for 15 minutes. The sodium hexametaphosphate is similar to laundry detergent. It works to break down the cohesion between the particles so that the individual particles will not stick together. Note, this is a deviation from the ASTM standard. ASTM suggests that you let this set for up to 24 hours. We will only let it sit for 15 minutes in the interest of time. While the soil is soaking for 15 minutes, you can use this time to calibrate the hydrometer. Each hydrometer is unique and will have its own unique zero correction factor. To determine the zero correction factor, lower the hydrometer into a control jar. A control jar is just a water solution with sodium hexametaphosphate, without any sort of soil in the water. The hydrometer will eventually stabilize. The reading on the hydrometer staff from the top of the meniscus to the 0 mark is the zero correction factor. Also noted is the meniscus correction factor. The zero correction factor is the distance from the 0 mark to the top of the meniscus on the hydrometer staff. The meniscus correction factor is the distance from the water level to the top of the meniscus on the hydrometer staff. Record the meniscus correction factor and the zero correction factor on your data sheet. After the 15-minute soaking period, transfer the sodium hexametaphosphate soil solution into a dispersion cup. Use a squirt bottle with water to ensure that all the material transfers out of the evaporation dish into the dispersion cup. Fill the dispersion cup with water until the water level is about halfway up the cup. Mix with a shake mixer for 2 minutes. Pour the sodium hexametaphosphate solution from the dispersion cup into a clean sedimentation jar. Again, using a squirt bottle with water, ensure that all the sediment has transferred from the dispersion cup into the sedimentation jar. Okay. Cap the cylinder with the rubber stopper. Agitate the solution for 1 minute by turning the cylinder upside down and back 30 times in 1 minute. After 1 minute of agitation, remove the rubber cap and use your water squirt bottle to ensure that all of the sediment is off the cap as well as off the sides of the sedimentation jar. Fill the sediment solution up till it is at the 1,000 milliliter mark. Place the sedimentation jar on a table where it will sit undisturbed for the next 24 hours. After 2 minutes of placing the jar on the table, insert your hydrometer and take the first reading at 2 minutes. Record the reading on the hydrometer staff at the top of the meniscus of the dirty water. After the reading, remove the hydrometer, place it aside, and insert the thermometer to take a temperature reading. Continue recording the hydrometer and temperature readings at approximate elapsed times of 4, 8, 16, 30 minutes, 1, 2, 4, 8, and 24 hours. From the hydrometer time history, a gradation of the particles falling out of the solution can be calculated. That, combined with the particle distribution curve determined from the mechanical sieve, will give a full grain size distribution of the provided soil.